find the reference number for each value of t. So when we're given a t value, in this case the radian value, what we're doing is we're trying to find where that is on the unit circle and then find the shortest distance from that to the x-axis. And so I would recommend using a unit circle to help you with this until you get more used to it or until you have the unit circle memorized. So our first t value is t equals 5 pi over 4. So what we're going to do is we're going to go to the unit circle and look for 5 pi over 4. So starting at 0 and going around, we see that 5 pi over 4 is here in quadrant 3. And so now this is where we are located, and we want to find the reference number, which is the shortest distance from here to the x-axis. So how far is it from here to the x-axis? What is this distance? What is this number? And so from here to the x-axis is pi over 4. So our reference number here is pi over 4. And that's how you find it. Now what if we give kind of an odd one here? What if we have t equals 7 pi over 3? Well, as you look at the unit circle, you're going to see, no matter how many times you go around, that 7 pi over 3 doesn't exist on here. No matter where you look, 7 pi over 3 is not here. What this is that when you go one complete revolution around the unit circle, that is 2 pi. And if you look at 7 pi over 3, that's more than 2 pi by just a little bit. So what that is when we are going around the unit circle, we can say there's pi over 3, so that's 1, 2, 3, 4, 5, 6 pi over 3, which is 2 pi. So one revolution here is 6 pi over 3, or 2 pi. But we wanted 7. So after we've gone around 6 steps, 4, 5, 6, we just keep on going. And this is step 7, 7 pi over 3, which is just pi over 3. So it just repeats. So this is right where we're at. And we want the shortest distance from here to the x-axis. How far is it from here to here? And that is pi over 3. So the reference number for 7 pi over 3 is pi over 3. What if our t value is negative? In this case, negative 4 pi over 3. Well, we know that negative goes clockwise instead of counterclockwise, so we're having to go this direction. But again, I think it's easier to go the counterclockwise direction and look for 4 pi over 3. So when we do that, going around, we see that 4 pi over 3 is here. So it's essentially half a circle around and then pi over 3 more. So that's what we're going to do. We're going to go from here, and we're going to go half a circle around and then another pi over 3. So 2 pi over 3 is equivalent to negative 4 pi over 3. And so now we want the distance from here to the x-axis, the shortest distance. And this distance here is pi over 3. So the reference number here is pi over 3. Now let's do it one more time for 5 pi over 6. So 5 pi over 6, this one's a little bit easier than the last two because it is on the unit circle. So we just go around starting at 0, and we're going to go to 5 pi over 6, which is right here in quadrant 2. So we want this reference number here, the distance from 5 pi over 6 to the x-axis, which is just a pi over 6 distance. So the reference number here is just pi over 6. And again, I would recommend use the unit circle until you get more used to it or until you have it memorized, and then it should make it a lot easier.